We're hunkering in the bunker, Moon and Matt today. Hunkering in the bunker, Moon and Matt today. So volume is all about the space inside an object. Let's say this jar right here. We can think about a unit that might measure it. Maybe this rice that I got right here. Lovely jasmine rice. Not the king of the rices, but a good rice nevertheless. How much space is taken up inside here by the rice? This will be my unit. We're going to see the volume of this jar based on rice. As I say, got my jar, got my rice. I'm going to take my rice and pour it in. Fill up this jar. So, I filled up my jar finally, and I've got a little bit of a problem. Firstly, I've made an absolute mess. Secondly, I didn't really manage to count the rice as I put it in. I mean, I've got a lot of time on my hands with this whole virus right now, but even for me, that seems like a lot of effort to count all that rice. So volume is the space taken up something, and we can take a unit. If we take our rice as being the unit, if you look at that piece of rice, and that piece of rice, let's have a look side by side, you'll notice that this one is slightly smaller than that one. So they're not a regular unit. Also, even if I could take these out and once again count them, I've got another problem, which is that you might notice that in between all these grains of rice, there's space. So when we want to find volume, we want to pack our whole container without any space. But if we have something like this, which is an irregular shape, I can't do that just using a unit. I need to use some math with that unit too. So Mr. House really should think about things more often so he doesn't make a massive mess and waste his time. So this is where regular units come into, and that's what we're going to talk about when we're down in the bunker. So here we are. You're going to have to trust me, we are in the bunker. We're going to talk a little about volume. One, we learned upstairs. You need to fill the whole figure. Two, you need a regular unit. And then the third thing that we start to realize is that we're going to need a formula. And a formula just means a way of doing things mathematically. Okay. Imagine that I have a box and I put inside it a bunch of cubes. These cubes will be 1 inch in each of their dimensions. What that means is that they are 1 inch all the way around. This right here, you can see I've got 1 box, 2 boxes, 3 boxes, 4 boxes, 5 boxes, 6 boxes on going in a row here. Behind them I can see there's another box, so there must be 2 sets of 6 boxes. 2 times 6 boxes. But I have 2 layers. So I must have, for every box on this spot here, I've got to have another layer. So I've got 6 boxes here, but there must be 6 boxes behind them. So I must have 12 on this layer, and then I've got another layer of 12. So I must have 24 boxes. This is our formula that we come up with as a way of creating our volumes. Length times width times height. Length times the width times the height. As we know, because of the law of commutability, it doesn't actually matter which way around we do those multiplications. What does matter though is this part here can tell us something, if we put in parentheses, just about what our base is. And this tells us about how many we have going up. So here's a challenge. For Monday, how many boxes can we create? Sorry, how many ways can we rearrange? Let's start this again. Rearrange our 24 boxes so that we have a rectangular prism made from those boxes. What I mean by that is I don't want any irregular shapes where it's not a full row or not a full layer. Okay, so I can't take this box and put it up here and say, well, it's 24 boxes. I've got to make sure that I have all of the possible ways. And I want you to think about this parenthesis, because if you think about it, a 2 by 6 box, 2 by 6, and I just realised that I did this wrong in terms of length times width, because technically that's the length. Well, it actually proves what I'm about to say, which is that I can switch these two numbers. It's the layers that change my box. So we're going to say, how many different ways can we create a box that holds 24? So that's today's visit to the bunker. We've formalised our volume. We've come up with a challenge, which is to repeat it, is to try and come up with a rectangular prism which has 24 as its total volume in as many different ways as possible by Monday. That's your aim. This has been surprisingly normal as far as my videos go. No songs, no nothing, but hopefully the learning. So that makes me feel really, really weird. I really don't know what to do, and I'm not doing anything that's off topic. So let's I'll be on the fringe up there. That's what I'll finish with. That's enough off topic. You got in there, right there. You got Alan Bennett. He became a great playwright, and next to him, your man Peter Cook.